No? Not yet? Oh. All right, well, let's get to it. So, what I wanted to do today, and then also again on Monday, is talk about what all the different parts of computers are. Now, those of you who have built your own machines kind of know probably most of this, but I don't know, maybe there'll be some parts of it that you've never actually thought about. And so today, what I want to sort of do is talk about what the parts are and sort of how you would select parts if you were to build a machine. Now, the irony of this is, especially since a good chunk of you guys are freshmen, how many of you bought a computer this summer or built one this summer? Really? Not that many? Oh, okay. Well, wouldn't this have been handy to know like 3 months ago? Maybe? So, anyway, so obviously with modern computers, right, you got a choice, right, between desktop build and a laptop. Now, what does everybody have? What do you guys have? Who's got laptops? Okay. Who has a desktop? Who has both a desktop and a laptop? Okay, right. So, because obviously the two serve different roles, and unless you're going to get one of those gaming laptops that's like 4 inches thick or something, then you know that you can game on a laptop, but no, it's not the same. So anyway, all right. So if I wanted to buy a laptop, what kind of thought process needs to go through my mind? Like, what considerations do I need to be making? So, yes, okay, that's probably the biggest thing. The first, how much money do you have to throw at the problem? Okay. So what would be a reasonable amount of money to spend on a laptop? Well, it depends on what you want to use it for, right? So those of you who have laptops, what do you want your laptop to be able to do?
Anything I need it to do.
Okay, so when you say need, what do you mean?
Well, at the time I got this computer, I had no idea. I just knew I was coming here. I needed a computer, and I wanted to make sure that whatever you guys wanted me to do, my computer was able to give me.
Okay, and so generally speaking, what does it want you to be able to do? Yeah. Write papers, use Excel. You know, if you go in computer science, obviously some programming, right? So what'd you end up buying? Looks like a Mac,
MacBook Pro?
right? M1 or Intel?
No idea.
Let me look. Intel, okay. Yeah, which worked fine, right? You'll be able to do some programming on it. You'd be able to even play some light games. You know, anything college-wise that you need to do, you'd be able to do. Okay, now, what about, did anybody buy or does anybody have like a Surface Pro, like one of those convertible things? Yeah, all right, so why'd you pick that? Right, okay. That's probably the most popular answer, right? Because it sort of serves both role of as a tablet and a laptop. You can write on it as if you're, you know, like a tablet to take notes, but it's also a computer. You can flip it up and have the keyboard to type papers, right? Sort of everything in one device, right? Which is certainly quite useful. Now, deliberately, I don't do that, right? So I keep separate devices for both of those things, but that's more of a function of me being a teacher than me being a student, right? If I were a student, then the solution would be completely different. Like, I want them to be separate devices, and my laptop needs to do everything, right? From game design, heavy-duty programming, everything I do with teaching. It's running the streaming software, right? So that thing is a beast. And it, you know, costs $2,500, but, you know, I use the hell out of it. So, right, so those are sort of the considerations that you'd want to do is, you know, what exactly is its purpose, okay? Now, a laptop, right, when you buy it, for the most part, it's just a thing in a box. You come, you plug it in, and you turn it on, and bam, it does everything. You don't really have to worry about what's actually on the inside of it, except for the buying part. So let's say we want to go buy a Mac. We go to, of course, apple.com, and let me maximize that. And we're going to shop for college because we want to get the sweet discount. Oh, and the free AirPods, too. But anyway, so let's just go to the Mac and let's see what we want to buy. All right, so here are our choices. Right, so let's say that we've decided for sure we want to buy a laptop. Okay, price is obviously going to be a consideration. So if we look at the three laptops, the 16-inch MacBook Pro, that's what I'm running. Well, let's see how much this thing's going to cost. Whew, that's a hard nope. Okay, so let's go back to, say, a 13-inch Pro. Okay, a little bit more reasonable price-wise. Those seem like reasonable prices. Can you get a PC for cheaper? Yeah. But I don't know. There's nothing like Mac engineering. They're just so beautiful. It's like, is anybody really into like cars, fancy cars? Maybe not owning them yet, but right. I mean, there's Ferraris for a reason, right? Okay. Anyway, so when we see all these specs here, right? What's the difference between these two models of computer? Yeah, the storage space. That's the only difference between these two. Okay, so this line right here, right? All right, so when we say 256 gigabytes of SSD storage, what are we talking about there? Like, what are we storing? Yeah. Everything, right? And that data is, of course, retained when you turn the computer off. Okay? So that's long-term storage of your stuff, your Word files. Of course, nowadays, a lot of things also live in the cloud, but if you're using like Box or Dropbox or something, most of those you can, or Google Drive or whatever, most of those are configured in such a way that they keep a local copy and then they synchronize with whatever's online. The benefit to that is what happens if you get on an airplane and there's no Wi-Fi? Well, then your stuff's all still there, and then it'll sync up when you land. It's real handy for teachers who fly all over the country. Okay, so what's the difference then between this, quote, unified memory, whatever that is, and the SSD storage? Okay, so what's the difference? What is memory? Yeah, RAM is the technical term for it. Right, okay, so it's sort of like your short-term memory for what's actually being processed by the computer at the moment you're using it. Okay, the more of it you've got, the more things you can sort of do simultaneously, or you know, in certain professional applications like graphics and video editing and stuff will take as much RAM as you can throw at them. Okay, now this particular thing, what it says unified here, what it means is, so let's actually go up to the line above it and talk about that for a second. Okay, CPU and GPU, what's the difference? And for that matter, what do those stand for? Yeah, G is for graphics processing unit, and then C is central processing unit, okay? So the GPU is what does all the screen stuff and 3D graphics, games, that sort of thing. Although not exclusively games. You can use 3D graphics chips to accelerate like video encoding and machine learning and a whole bunch of other kind of applications that aren't game related. Okay, 8-core CPU, 8-core GPU. So what is a core? So a core is actually just a full-blown processor. Okay, and so this one has basically 8 of them built into a single chip. Now, back in my day, computers only came with a single core. It wasn't until the early 2000s that you started seeing in the consumer market multiple core machines. In the professional world, they'd been around for a long time. But what that means is that your computer can literally do two things simultaneously, rather than having to do one thing, swap and do the other thing, and then go back to the first thing, okay? And in this case, then, it could theoretically do 8 things at a time, because you got 8 cores. Okay, GPU, architectures for those are very different, and that's a long, kind of discussion. It has this thing they call the neural engine, whatever. Some of this is just Apple marketing gobbledygook, but so this unified memory, we'll see this when we sort of start picking parts for a desktop, but graphics cards have memory. The computer also needs memory. And on desktops, typically these are 2 totally different types of memory. One of them is on the graphics part, the other one is on the motherboard for the processor, and they don't mix, so to speak. The way Apple's engineered it is that both the CPU and GPU use the same pool of memory, and that does have some advantages, but it also can have some disadvantages. Yeah, so that's what they mean there. Okay, and then the rest of it is, how many ports does it have and all of that stuff. Okay, so questions? Preguntas, fragens? Maybe let's look at a PC for sort of comparison's sake. So let's just go to Microsoft. How about that? Let's pick a Surface. Laptop, tablet, Surface Pro. Ooh, we'll do that one. No, go away. Okay, so this is why you picked this one, right? Because look what you can do. Get the pen, write on it like you would a tablet, but it's also a full-blown computer. All right, so let's say we wanted to buy one of these. So, all right, configure now. Ooh, what color do we want? Okay, but anyway, right? So the Platinum, ooh, $17.99. Oh, and then they want to sell us this. By the way, if you buy a computer, don't buy Office because you get it for free as part of being a student here. So no need to spend money twice. Okay, no. Oh, right. What's the other thing that of course, everybody and their mother is going to try and sell you? Yeah, the extended warranty. And how many of you guys get spam phone calls like, our records indicate that your car's extended warranty may be about to expire? Like, even if you don't have a car, right? Maybe, the word may is really critical there. So, yeah. Welcome to America. Okay, and then this particular model actually can have a SIM card, so it would be able to connect to the mobile data network instead of just Wi-Fi, which if you were in the business world might be kind of handy, right? Because no matter where you are, you'd be able to have net access. Okay, and then there's the keyboard and the pen and all of that. Okay, but let's look at what the actual configuration is. If it will give me actual details, that would be huge. I want technical specifications, come on. All right, anyway, 16 gigs of RAM, 512 gig SSD, right? So more RAM, more processor. What kind of processor would be in this thing? What do you guys just guess? Well, who would make it, first off? The processor. Who makes processors? Intel. Who else? AMD. Those are the big ones in the PC world. And then in the mobile world, it's all ARM architecture. Okay, Apple designs its own stuff, although they don't have a fabrication plant, neither does AMD. Right, so has anybody tried to buy an Xbox or a graphics card in the last 6 months? And it's a nightmare? Okay, why is it a nightmare? Well, there's many reasons, but what's the problem? Well, yeah, there's scalpers, right? People who are buying them to flip them on eBay for a profit. But why are there scalpers? I mean, there's always people who want to make a buck, but what's enabling them? Yeah, for graphics cards, that's the other thing people are after them for is crypto mining. Okay, but what market conditions lead to scalping existing? Yeah, scarcity, right? So high demand, low supply. And that means that somebody's going to step in to try and make a buck off of that and take advantage of the high demand and low supply. If you could snag a Xbox at Walmart for retail price and flip it for twice that much money on eBay, right, that's a pretty good afternoon for doing basically nothing. Yeah, so really it's the high demand along with the production that isn't able to meet that demand. And the big reason why there's such that crunch on the production side is chips, okay? So AMD's chips are all fabricated by Taiwan Semiconductor. So are all their graphics chips. And guess what's in both the Xbox and PS5? Stuff that AMD designed, both of them, right? And of course, AMD's desktop processors and their desktop graphics cards and a whole bunch of other things are also manufactured by Taiwan Semiconductor, including Apple's chips, right? So a lot of people are going to the same company on the not very big island of Taiwan, right, to get processors. Now, Samsung also manufactures them. NVIDIA is using Samsung for some of its graphics chips. But there's just not enough fabrication space to go around right now is basically the problem. And of course, getting the chips is only half of it, because then you still got to put it in the computer or Xbox or whatever, right? So there's still an assembly component to it. It's not like you just hand out a chip to a customer. Yeah, okay. So now Intel has its own fabrication facilities, which gives them an advantage in the sense that they're sort of vertically integrated, right? They design it, they build it, although they're having their own host of problems with their fabrication technology. So anyway, so that's the laptop world. Let's say we wanted to build a desktop PC. Okay, this gets a little bit more complicated because in a laptop, right, in order to get it this thin, all of these components are kind of mashed together. On a desktop, or big computer, they're all, well, most of them are separate pieces. So we have to select each of these separate pieces. You get a lot more options in terms of configurations, and you can get a lot more power out of it because it's in a box, yay big, rather than a thin, tiny laptop. Okay, so let's go shopping. Where should we go shopping? That's a good place. PC Part Picker. Okay, yeah. So there's a couple of websites like this. There's also PC Hound, and there's a third one, and I'm blanking on its name. Huh? Well, Newegg's a retailer. These guys, so this site, like, you pick the parts, and it'll actually look and find which retailer is least expensive per part. But it's also kind of a handy thing. So they're going to have some pre-built things on here, build guides, and so if you've never done this before, but let's just start from scratch, okay? So here are all the parts that we're going to need, right? And some of these are potentially optional, but most of them are required. Okay, so let's just go through the list. CPU, we need a processor, right? CPU cooler. Well, these things put out heat, a lot of heat. And so we need some sort of thing to cool it off, okay? Either a big hunk of metal with a fan on it, so a heat sink, okay, or a liquid cooling unit, which is if you really want to do it properly, okay? That has fans and radiators and frankly is much like a car radiator, right? So how is your car engine cooled? Huh? Yeah, okay. So you circulate oil and coolant through the engine block, Okay, that heats up, then what happens? It goes to a radiator that's on the front of the car, and there's a giant fan in front of it, blows air over that radiator and dissipates the heat, and then your car doesn't explode. Unless you've got like an air-cooled Porsche or something, in which case, you know, the motion of the car, the air flowing over the engine block cools it off. But anyway, these things can generate significant amounts of heat, and so we need something to deal with that heat. Otherwise, you know, your processor could fry an egg without too much. You put a little skillet on it and fry an egg. Okay, motherboard. What is a motherboard? Yeah. Yeah, everything plugs into the motherboard. Processor slots into it, your graphics card pops into it, your RAM sits on it, everything. So that's what connects all of it together. And the motherboard is going to have a lot of the things like your USB ports are integrated into it, sometimes even sound, your networking, like if you're going to plug in networking, even Wi-Fi is all built into it. There's a lot of features that have gotten packed into motherboards over the years. Back in the day, every single thing you wanted was a separate little slot card that you had to install on the machine. But a lot of those things have kind of become unified. So it used to be the case that, like in my first computer, I had a sound card, I had a video card, I had a networking card, I had a modem, back when you had to use the telephone to connect to the internet. You guys may be a little young for that, but did anybody have dial-up when you were younger? Yeah. Didn't it suck? It was slow as crap. And if somebody picked up a phone in the house, you got disconnected. And yeah, horrible times in the Stone Ages. All right, anyway, so a lot of that's now integrated onto the motherboard, so you don't need separate cards for everything. Memory, that's going to be our RAM, like we talked about before. Storage would be, an SSD is probably the type of storage that we'd pick, but it's not the only kind. Video card, we may or may not need this. It kind of depends on what you want to do with the system. If you want to play games with it, we'll assume that that's what we're building this thing for, is to play, Battlefield or Call of Duty or something. Or what is it you guys play nowadays? Huh? Well, I knew that, but that doesn't mean you guys don't play other things. Okay, let's talk about Warcrack.
For the Alliance.
Yes, okay. So I have a very strict rule for myself and that I recommend to students. No MMOs in college. You do not have time.
No, I quit right before I came back.
Good, okay. Yeah, you do not have time to be doing that. I mean, like, have you seen the South Park World of Warcraft episode? That is 100% true, right? You do not have time to become the fat guy covered in pimples, with the like wrist brace thing or whatever, living in a basement playing Warcraft when you're supposed to be going to class, right? I have seen more GPAs do this thanks to Warcrack. Okay, so don't do it. Warcrack is bad, okay? Shouldn't do Warcrack. Drugs are bad. Yeah, okay, anyway, but we'll assume that we want to play Call of Duty and fun stuff like that, okay? Case, well, you got to put it in something, right? And that keeps all the components secured. Power supply, well, okay, so why do we need that? What kind of power comes out of the wall? Well, yes, but elaborate, like details. Huh? Yeah, 110 volt AC, alternating current, okay? What kind of power do you need to run a computer? You need direct current, okay? So alternating current switches back and forth, the polarity, 60 times a second. And direct current is what you need for most electronics. So the power supply is going to convert from the wall power to DC power at the appropriate voltages for the computer, okay? And depending on how much stuff you're going to throw in your machine, you may need a pretty beefy power supply, like on the order of 600, 700 watts, maybe even more. If you're building a crypto rig, then, you know, you need a lot more juice, okay? So we'll have to choose one of those, and then operating system, basically, you know, you're gonna buy a copy of Windows. And then some of the extra stuff that you might want, like, well, a keyboard, a mouse, maybe you want a webcam if you're streaming, or headphones, or whatever. Fans, thermal compound, you know, you could go crazy with this. All right, so let's start picking. So I want to play Call of Duty. Let's pick a CPU. All right, so what seems like a good buy? Oh, and let's also, for the sake of demonstration here, pretend that our dad is a Fiji, and so money is no object. Okay. Yeah. We hawked a few Xboxes, and so we can spend as much money as we want. Okay, so they're going to be listing things here sort of in order of popularity to some extent. But let's kind of look at some of the things here. So we got a column for core count, right? We talked about what a core is. So, you know, we can get things that have 6 cores, 8 cores, 12 cores, even 16 cores. That's about the most you can get for a consumer-grade desktop at this point. Core clock and boost clock, basically, this is how fast the processor runs. And what this boost clock thing is if the processor is not too hot, it will operate faster than if it starts to get too hot. It'll slow the clock down to keep it from overheating, okay? And so if you're running only one program really, and that's it, then you can run the core that program is running on at a faster clock rate so that program runs faster. You know, it's great for like video encoding and things like that. Provided that you can deal with the heat that it's going to produce by operating at full bore, okay? If you've got a good cooler, like a liquid cooler, then that's great. And if the processor starts to get too hot, it'll clock itself down so that it doesn't overheat, okay, is basically the idea. And that's related to this thing, TDP, thermal design power. So basically, this is basically how much heat at maximum performance is going to be produced, although that's not entirely accurate. But, and so how much heat are we talking here? 65 watts, 105 watts, 125 watts, right? That may not seem like a lot of energy or heat, but how many of you guys have touched a 60-watt light bulb, right? Back when they were incandescents. You know, nowadays we have LEDs and stuff, but you could burn your finger pretty easily on that thing, right? So, yeah. So this is quite a bit of heat, and it's quite a bit of heat in a very small space, right? Because the processor is, you know, basically the size of like a silver dollar or something. Okay, integrated graphics. Some processors have a graphics hardware on board. Not all do. And for our purposes, let's deliberately choose one that doesn't. Okay, so like I said, since Dad's a Fiji, we're going to go with this guy, the 16-core beast. Okay? All right, now, we need to choose a CPU cooler. We also need to choose a case. Let's actually pick the case first. Okay, now one of the things that I really hate about the PC world nowadays is if you start picking cases and fans, those of you guys who have done this recently, what's the real big thing in the PC world right now? Like case design and stuff? Well, yeah, tempered glass and RGB everything, okay? And you know what I don't like? Both of those things, okay? So, yeah, so some of these are like ridiculous. Like, let me click on this one, right? Huh? I like the clean simplicity of steel. Okay, now, look, that's an age thing. When I was y'all's age, I would have been all over this, okay? Like, in fact, when I was y'all's age, I actually had a computer case that was 100% made out of plexiglass, so the entire thing was see-through. Seemed like a good idea until it starts getting dusty, and then it looks like complete crap. That was not a good phase of life. Okay, anyway, so let's just pick something like, I don't know, this one's, okay, that doesn't look too ridiculous. Huh? Not yet, yeah. All right, so let's add that. And in particular, what we need to look at are some of the specifications. What size motherboard does it take? Okay, motherboards come in different sizes. ATX is sort of one of the more common ones. It's a rectangle, 9.6 inches by 12 inches. You can get mini ATX, which is 9.6 by 9.6. You can get smaller ones, ITX. That's the next time I build a system, I'm going to go real small. But yeah. Okay, anyway. And then the other thing that we're going to need to consider is, so let's say that we want to do liquid cooling. We need to know what size radiator we can put in this thing. So if we kind of look through the pictures, you can usually figure this out. Or actually, let's just go to the website and see the specs. All right, tech specs. Okay, so here's all the specs, the size, the weight, that sort of thing. But what I really want to look at is here, radiator compatibility. So radiators come in a variety of sizes, and fans come in a variety of sizes. But the most common for CPU cooling are either 120 or 140 millimeter fans. Okay, and then a 240 millimeter is two 120s next to each other, right? So it's rectangular. 280 is two 140s next to each other, and 360 obviously is three 120s. So we'll put probably a 240 or 280 on this thing. That should be sufficient. But we need to know what's going to fit in the case before we pick the cooler that goes with it, right? So, all right, so it'll fit, let's say a 280. That's probably a pretty reasonable size to go with. Okay, and so let's go back to our here, and let's pick the CPU cooler. Okay, so I want a 280 mil liquid cooler. Okay, and then we can kind of see some popular ones. We can look at the different prices, you know, that sort of thing. Okay, you guys like this whole ridiculous RGB thing. Look at that, right? Looks pretty sweet, right? Actually, you can do some cool stuff with the colors, like make the color dependent on the CPU temperature, and so you can just visually see like how hot the thing's running, or you can just go for like the disco rave here, right? Pop some Molly and, or don't, because drugs are bad, okay? Okay, so let's pick that. Most of these will come with the fans that you need for it. Okay, great. We need to choose a motherboard. Now, because we picked a processor manufactured by AMD, we need a board that has a socket that can fit the AMD processor. If we had picked an Intel chip, we would need a board with the appropriate slot or socket for an Intel processor. They're not the same. They used to be back in the day. Okay, so it used to be that you could put an AMD or Intel, or even there were a couple of other manufacturers back then, all in the same motherboards, and it would work. Okay, but they've kind of gone their separate directions, and so you can't mix them. All right, so we need to pick a motherboard, and so here's where we have to be careful, because, for example, some of the ones in this list are Intel ones. Actually, no. Looks like they filtered them out. Because we picked an AM4, AMD's socket design, it's only showing us those boards, okay? All right, so let's see. This looks good. Like I said, Daddy's a Fiji. Okay, so this is what a motherboard looks like. All right, so what are all these different slots on the thing and ports and blah, blah, blahs? So what's this guy here? Yeah, that's where the CPU is going to go, okay? And it's a little hard to see on this, but we'll see this when we take these things apart next week. Now, Intel looks a little different, but you see all these little dots? Those are actually very tiny holes. And on the underside of the processor are a bunch of very, very tiny gold pins. The pins all line up with those holes, they go into the holes, and then you lock it down with this little lever thing that's that metal piece there. Okay, and that's how the processor makes electrical contact with the motherboard. And the latch keeps it from like popping out, basically. Okay, now, that's different than Intel. How do Intel's chips look? Has anybody done this recently? Yeah. Yeah, the pins are on the board, and the processor has little gold pads on the bottom instead of holes. And then those make electrical contact. AMD is going to switch to that kind of design with their next chip sort of packaging. But a little different, but that's okay. All right, so that's where the processor will sit, and then the heat sink, the fan thing that we picked out, would bolt to the top of it, and you use these, where these screws are basically, are brackets and holding it in. And now, any of you guys ever change a tire in a car? Yeah, not exactly the most fun thing to do, but you've done it. Okay, when you're tightening the lug nuts on the wheel, how do you do it? Huh? Yeah, you do it in a star pattern, right? You tighten one, then you kind of, you don't just tighten this one all the way and then kind of go in a circle. You do the same thing when you're bolting a cooler onto a motherboard for the exact same reason. And it's basically, you don't want to have it lopsided in any one direction. So if you do it in a star, it kind of evens it out. So although obviously there's only 4 here instead of 5 on most cars, but you get the idea. Okay, what are these little slots here? There's 4 of them. Yeah, that's where your RAM is going to go. And again, we'll see this next week, but you see this little notch here that's not quite in the middle? What's that there for? Yeah, you can only put it in one direction. I mean, if you really, some of you football players could probably get it in the other direction, but it's not going to work, right? So you can only put it in one direction. The other thing, you'll notice that the processor has, there's a little notch there in these corners, right? And that means that it's very obvious if you're trying to put it in the wrong way. You got to be careful with that, obviously. Okay, so this little port here, these two, and this sort of wide one there are where the power plugs in. Okay, so you get lots of different voltages. And this thing with the ridiculous logo on it, underneath of it are a couple of things. All the USB ports and all of that stuff is down there. And then also this little hunk of metal, there's sort of auxiliary chips that allow the processor to communicate with other components. Those also get hot, and so they have these metal heat sinks on them. They don't get nearly as hot as a processor, main processor, so they don't need a very big heat sink, but that's what's there. Okay. Then these ports over here is where you would plug in some hard drives, although you can also put SSDs under this metal plate. Let's see what else. Okay, these 2 big slots, what are these guys? Yeah, that's where you'd plug in your GPU. Okay, so that's the graphics. Now, for the most part, on a consumer-grade board, we only ever really put 1 graphics card in. It's not worth it for games to put more than 1 in. For crypto, yes, but that's not what we're up to. Okay, and then you got all these little things down at the bottom. These guys are fan headers. There's stuff where you would plug in like the power button on the front of the case and extra USB ports if you want them and that sort of stuff, okay? But that's basically what the motherboard's going to look like, okay? And so let's just say, okay, we're happy with that one. Which one was it? This one. Okay, so let's add that. Okay, so far so good. We need to pick some memory, and we need to pick a graphics card. Ooh, let's do the fun part. All right. Well, like I said, Dad's a Fiji. So let's sort by price. Now, this is sort of ironic because here we go, this 3070 Ti, should this be $1,500? No, it should be like $700 or $800. Okay, so this is where the scarcity is going to kind of bite us because this is the component that's hard to find right now, are the graphics cards. Okay, and so like, let's see if we can find a, let's go crazy. Here we go. Let's go with the 3090, right? Oh, and this one, by the way, graphics cards also get hot. This one comes with its own radiator and fans. We got to do that, right? Where? Oh, here? Oh, anyway. Okay, so we got that. A ridiculous thing. And now we would have to worry about could we fit that into the case, okay? A big case is probably going to have plenty of room for multiple radiators. A real little one, no. It should oh, no, it's not going to fit. All right, what's the details? Okay, that's not a big deal. Yeah, okay. So, yeah, so it knows sort of common parts and knows if you're going to have issues putting them together, but that warning that it gave us isn't a big deal. Okay, we need some memory. How much do you want to put in this thing? 16 gigs is probably fine, right? And we've got to go with the ridiculous RGB, so let's do that. We can add more memory if we want. Let's pick an SSD. Yeah, okay, so let's go with this one. 2 terabytes, that looks good. And we already did the video card. Okay, so basically the last part is the power supply. Now, the nice thing about using one of these part picker kind of things is it sort of will give you an estimate as to how big of a power supply you need as you add components. This is why I left this part for last, okay? Because our estimated wattage in terms of how much energy we need to deliver to the whole thing, 564 watts, okay? So what size supply should we buy? Yeah, so I would buy at least 600 and probably 700. I usually leave at least about 100 watts of room above the estimate for 2 reasons. One, you may update, put a new part in later that needs more energy. The other is that power supplies aren't 100% efficient, right? And they sort of go down in efficiency over their lifespan. Okay, so if you sort of factor that in at the beginning, and let's say we put an 800-watt thing in here, then we're not going to use all 800 watts, but it's there, okay? So power supply, and here's an 850, close enough, okay? All right, so what's our grand total here? Woo! Okay, now, of course, where is most of that cost coming from? The GPU, right? And these things should not cost $3,000, right? That's about double what it should be because of the supply shortage. But anyway, we at least get the idea. Okay, so, question, preguntas, fragen. No? Okay, so what are we going to do today? Okay, so Monday I'm going to wheel in a cart full of old computers, and some older than others. I've also got a couple of dead laptops and a hard drive that actually has the top removed from it. So we can actually see what some of these things look like. Yeah, so Monday is going to be a bunch of old computers and a bunch of screwdrivers, okay? And you're going to take it apart and identify all the components, okay? Some of which are going to look a little different than what we did today. Some of them you may not even recognize. Because, like I said, some of these machines are older. Like, anybody ever remember using a floppy drive? Yeah? Or as youngins say nowadays, oh, look, you 3D printed the save icon. Oh, no. Yeah. So we'll kind of get our hands dirty Monday, taking apart some of these old machines and looking kind of how everything is laid out. Several of the machines that we're going to look at are like Dell desktops, where they're deliberately made a bit more compact than a gaming rig would be. But these used to be computers in a computer lab here on campus someplace, right? So, they obviously had a different purpose than a gaming PC. Right. So that's what we'll do Monday, and then Wednesday and Friday we're going to start kind of doing circuit level stuff on a breadboard with transistors and lights and things to kind of see, all right, the transistor was the magic piece that kind of made the computing revolution work or be able to compactify all of it. And so we'll talk about a single transistor, how does it work, and then of course the fun part is what happens when we start putting multiple of these together. What can we do with it? So that's basically the idea. All right, good? All right. And you guys have all hopefully seen on Canvas now, there's the 3 videos that are accessible. Part 1 and part 2 of this documentary, and then the third one's not a video, it's a podcast, the Grace Hopper podcast, and there's sort of like a comprehension quiz to go with it. Since it's the first time that we've done that, what happens if you get a bunch of the questions wrong on the quiz? You redo it until you get it all right, damn it. Okay? And when you do that, write down your answers, particularly the ones that you know are right, because one annoying thing about the Canvas quizzes when you retake it is you still have to put in answers that you've already gotten correct. It doesn't just let you not skip those parts. I wish it wasn't that way, but I'm sorry, that's the way it is. Yeah, okay, good? All right, see you guys.